Hello viewers, it's Teacher Isaac here from Muna Educational Services. I am a teacher of mathematics and physics. Today we are going to talk about probability. Dear learners, probability is a measure of the likelihood of an event occurring or not occurring. You can have the probability of maybe excelling in your exam, probability of maybe giving birth to a baby boy. So that one means the chance of giving birth to a baby boy, or the chance or likelihood of excelling in your exams. Now, for you to understand probability, you need to first understand what we call a sample space. A sample space refers to the total number of outcomes that you get after performing a particular experiment. Take an example. If you rolled a dice, the sample space would be, you either get a 1, 2, 3, 4, a 5, a 6. That is the sample space for rolling a dice. If you tossed a coin, the sample space would be, if you tossed a fair coin once, the sample space would either be getting a head or a tail. Now, after understanding the sample space, dear learners, you also need to understand what we call an event. An event is a subset of a sample space. For example, I can tell you to get for me the event of obtaining an odd number after rolling a dice. So this event, we shall just go to our sample space and get the odd numbers. So we shall be having 1, 3, then 5. So someone can even go ahead to tell you that calculate the probability now of getting an odd number. So what you need to understand is the probability of an event like that of getting an odd number is equivalent to the number of events divided by the number of sample space. So the number of events here that we have would be 3. Then divide by the sample space, which is 6. So the probability of this event becomes 3 over 6. So that is just a brief introduction. Today, our main core for this lecture, we are going to talk about what we call probability tree diagrams. So let me just get this one off such that we dive deeper and understand probability very well. So, dear learners and viewers, what you need to understand, a probability tree diagram is a tool or technique that we use to generate a sample space. It makes the work of generating a sample space easy, such that you can calculate the probabilities that you want. So I've given you an example here. Let us try to go through it. This example says that a bag contains 8 red pens and 3 green pens. They are saying that 2 pens are randomly picked, one after the other without replacement. Someone is picking pens from this bag. Find the probability of getting both pens of the same color, then the probability also of the first pen being green in color. So now, what we are going to do, we are going to first draw the probability tree to try and see our total outcomes that we have in this scenario. So friends, we are having a bag. This is our beautiful bag. The bag is having 8 red and it is having 3 green pens. So they are saying that they are picking one pen, one after the other, without replacement. So let's try and see. So we are going to first look at the first pick. For the first pick, the person can pick a red pen or they can pick a green pen. So the probability of picking a red pen first is going to be equivalent to, it would be 8 divided by the total number of pens, which is 11. Then the probability of picking a green pen first, it will be equivalent to 3 divided by the total number of pens, which are 11. Take note, whenever you form a tree, this is now called a branch. The sum of probabilities on a branch should always be equivalent to 1. When you add 8 over 11 to 3 over 11, you'll get 11 out of 11, which is a 1. So now, here they picked red first. If they first picked red, we have to first analyze and see. If they picked red first, it means that the red pens now, they are going to be 7. And the green pens will remain 3 untouched. If they picked green first, it would mean that the red pens would remain untouched, they would remain 8s, but the green pens now, they would be 2. So friends, that is the first pick. Now let us try to analyze the second pick. For the second pick, if someone first picked red, they can pick red the second time or green the second time. So now this is the probability of picking red the second time. It's going to be 7 divided by the total, which is 10. Then this one here would be the probability of picking green the second time, and it would be equivalent to 3 out of 10. We also handle this one. If someone picked green first, second pick, they can pick red for the second time, and this one is going to be equivalent to 8 over 10. Or they can also pick green for the second time, and this one is going to be equivalent to 2 over 10. Try not to reduce them, first leave them as they are. So friends, this is our beautiful tree diagram. So we are going to go ahead and we try to calculate or answer the questions down here. They want us to get the probability of getting both pens being with the same color. So they want us to get the probability of both pens having the same color. For both pens to be having the same color, it would mean that someone would pick red for the first time and red for the second time. Or they would pick green for the first time or green for the second time. So this is what we are saying. They can pick red for the first time and red for the second time. Or they would pick green for the first time, green for the second time. So this is the probability of picking a pen of the same color. Now, picking from a bag, these are independent events. And the probability of the intersection of independent events is always equivalent to their product. So we are going to break it down. We are going to say that the probability of red 1 intersection red 2 is going to be equivalent to the probability of R1 times the probability of R2, that is red for the second time. I'm using a multiplication because these events are independent. Then the OR means addition in probability, the OR situation. So even this is independent, so we shall be having the probability of green first times the probability of green second. So we're just going to go ahead and we substitute. So here we're going to be having, this is 8 over 11 times 7 over 10, and plus, this one is going to be 3 out of 11, then times 2 out of 10.